The Great Pyramid of Giza stands as one of humanity's greatest achievements. Originally reaching a height of about 146 meters and constructed from nearly 2.3 million stone blocks, some weighing up to 80 tons, it continues to challenge our understanding of ancient engineering. How could a civilization without steel, engines, or modern machinery create a structure so immense, precise, and enduring? While myths have suggested aliens, giants, or lost super technologies, the real story is far more impressive. The pyramids were built through human intelligence, careful planning, and extraordinary organization. Rather than mystery, their construction reflects the peak of ancient problem-solving, discipline, and cooperation on a scale rarely seen even in the modern world. The Great Pyramid of Khufu, constructed around 2580 to 2560 BCE during Egypt's Old Kingdom, did not appear suddenly or by accident. It was the result of centuries of architectural experimentation. Early Egyptian tombs, known as mastabas, laid the foundation for working with stone and developing long-term construction techniques. The Step Pyramid of Djoser, designed by Imhotep, marked the first successful attempt to build vertically using stacked stone layers. Later projects such as the Bent Pyramid and the Red Pyramid show how engineers corrected mistakes, adjusted angles, improved stability, and refined internal designs. By Khufu's time, Egyptian engineering had reached a highly advanced and reliable system. Behind this massive project was a workforce very different from the slave labor often portrayed in popular culture. Archaeological evidence shows the builders were skilled, organized, and well supported. Around 20 to 30,000 workers operated in rotating teams called files. Many were farmers who worked during the Nile flood season. Others were full-time specialists, engineers, stonecutters, surveyors, and scribes. Excavations near Giza reveal bakeries producing thousands of loaves, breweries supplying beer rations, and medical facilities for serious injuries. Even graffiti inside the pyramids, with names like Friends of Khufu, shows pride, unity, and morale among the workers. Supplying materials for the pyramid required an advanced logistical system. Most limestone came from nearby Giza quarries, while the smooth casing stones were transported from Tura across the Nile. Granite blocks for internal chambers traveled nearly 800 kilometers from Aswan, demonstrating impressive long-distance planning and coordination. The Wadi al-Jarf papyri, written by an official named Merer, describe how stone was shipped by boat along canals connected to the Nile. The discovery of an ancient Nile branch near Giza explains how massive blocks were floated close to the construction site, greatly reducing overland transport challenges. Moving stones on land relied on simple but highly effective techniques. Wooden sledges dragged over wet sand significantly reduced friction, a method confirmed by modern experiments. Tomb paintings show teams hauling enormous statues and stones along prepared paths using ropes and coordinated effort. Copper chisels, dolerite hammers, wooden mallets, and levers enabled precise cutting and shaping. Every stage, from quarrying to placement, was carefully timed and supervised. This reveals a sophisticated administrative system capable of managing a project comparable in complexity to today's mega constructions. Lifting stones into place was the greatest challenge. Early construction likely used straight ramps, but as height increased, other methods were needed. Evidence suggests zigzag ramps, spiral ramps, and possibly internal ramps hidden within the structure itself. The internal ramp theory by Jean-Pierre Houdin gained support after scan pyramids detected unexplained voids. Levers, counterweights, and scaffolding helped position heavy blocks, especially granite beams, in the king's chamber. The Egyptians likely combined multiple techniques as construction evolved.
The pyramid's precision continues to astonish engineers. It aligns to true north with an error of less than 0.05 degrees, likely achieved through observing circumpolar stars or solar shadows. Its base is nearly perfectly level, possibly measured using water-filled trenches.
Geometry, astronomy, and proportional design guided the layout. These methods prove that ancient Egyptians possessed deep practical knowledge of mathematics and physics, applied with remarkable consistency and accuracy across an enormous structure. These accomplishments have fueled myths for centuries, but archaeology tells a clear story. From mastabas to smooth-sided pyramids, we see continuous innovation rather than sudden unexplained leaps. Every tool and method has physical evidence and logical development behind it. No trace of alien technology or lost advanced civilizations has ever been found. Instead, the pyramids stand as proof of what disciplined human effort, planning, and creativity can achieve when guided by knowledge and cooperation. The pyramid's legacy extends beyond stone and scale. They represent a society capable of coordinating tens of thousands of people, managing resources across vast distances, and applying scientific thinking long before modern engineering existed. Ongoing research, including muon scanning and excavations, continues to reveal new details. The decline of pyramid building was not due to lost knowledge, but to political, economic, and religious changes within Egyptian society. Standing at Giza today, surrounded by stones placed with purpose and precision, we witness human vision at its peak. The pyramids were not built by magic or mystery, but by people who understood their environment and worked together toward a shared goal. The true wonder of the pyramids is not how impossible they seem, but how clearly they demonstrate the limitless potential of human ingenuity when intelligence, organization, and determination come together.